Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 8 from the February-March 2019 International A-Level Cambridge Pure Mathematics P1 exam. This is from the 9709 syllabus. This is paper 1, variant 2 from February-March 2019. This also corresponds to question number 7 in my end of topic worksheet from P1, the fourth end of topic worksheet, which is about functions, inverse and composite functions. Now, this particular question is quite a long question, and what I'm going to do is I'm going to split it up into two videos because it's going to be very long. Part 4 I'll do in a separate video, okay, and I'll deal with part 1 and 1 to 3 in one separate video, okay, so that it doesn't become too long and the students can find what they're looking for. In fact, the student who asked me to answer this question for him, he asked me for question 8 part 4, but in order for me to explain it thoroughly, I'm going to go through the whole question from the beginning for those who need that. And a little side note, this is not supposed to be like I'm just reading out the mark scheme, okay? That's not what my videos are intended to be. Okay, so if you're looking just to see the answers and the mark scheme, then this is not the place for you. You can find it, you know, from the from different websites. Just you can find the website, the mark scheme. My intention here is to use these questions to help teach the concept to my students. So I'm going to maybe sometimes take a lot longer than you might expect to explain certain concepts. Okay, it's not like I'm taking the exam or I'm doing the exam in the time that you're supposed to do it. When you take the exam, no, I'm trying to use these videos to try to help students understand the concepts that we're supposed to know in order to, understand the topics properly. So just a little side note there. So it might be that I take, a long time to answer one mark question. That's because I'm talking around the topic, trying to make people understand, the concept. All right. So first of all, it says express x squared minus 4x plus 7 in the form x plus a squared plus b. So here we have a quadratic function. Now we know it's a quadratic function because it's in the form ax squared plus bx plus c. The highest power is x squared. There's no x in the denominator. This is a quadratic function. And when you have a quadratic function, one of the useful ways to express it is when you complete the square and write it in the form that they have asked us to write it in. Okay, that's called completing the square. And there's many advantages for us, or many benefits for us in writing an expression like this in such a form, as we'll see, as in fact we answer this question. Now, firstly, to complete the square, we want to end up with a bracket which is squared, as we can see very clearly there. Now, we have 1x squared, we have 1x, there's no problem, that's going to be an x there. This number in here, okay, basically this number here over here must be a square coefficient. The coefficient must be a square number, 1, 4, 9, and so on. In this case, it's 1, that's fine. And we want to write it as 1x inside, so that's perfectly good. When you square that, you're going to get x squared. Now, the other term inside the bracket is always going to be a half of the coefficient of the x term in the expression, and have the same sign as it. So this is going to be minus 2. Right, as we know, when we square a bracket, we basically square the first term, and then we multiply the two terms together and double the answer. So when you multiply these together, you get minus 2x, you double it, you get minus 4x. So that's why, if this is a 1 here, we just take a half of this coefficient, okay, with the same sign. All right, so this will give us, if we left it as this would give us basically x squared minus 4x, but then we'll have to also square this term to give us the constant at the end. If you expand this, you get x squared minus 4x plus 4. Well, we don't want the plus 4, okay? And so right now I'm not concentrating on that plus 7. I'm just concentrating on this part. Now, what we have here is not quite the same as that yet. They're not quite the same. This is basically going to give us x squared minus 4x plus 4. We don't want the plus 4, so what I'm going to do is I'm going to take away 4 from this. Now, what's that going to do? It's going to get rid of this plus 4. When I take away from 4 from this will become x squared minus 4x, which is exactly what we have there. It's the same. This and that are the same. What I've highlighted here in the question and what I've highlighted here are the same thing. Okay, but there's a plus 7 at the end, so I must write plus 7 at the end. Now, the whole thing is the same as this. So now they're equal to each other. Well, I can say they're equal to general. I don't have to write the equals here. That's fine. Okay, so now they're the same. So I can say our answer is x minus 2 squared. You have minus 4 plus 7, which is plus 3. So we have completed the square, and that is the answer to part 1 of question number 8. Okay, quite straightforward, but very, very important for us to know how to do such a thing. Okay, now for question 8, part 2, it says the function f is defined by f of x equals x squared minus 4x plus 7 for x is less than k, where k is a constant. State the largest value of k for which f is a decreasing function. Okay, so basically the domain of our function, this is the same function as we had here. Okay, so f of x is basically the same thing as what we just had up here, which we can write in this form, which will help us in this question actually. Okay, we need to find the largest value of k for which this is a decreasing function. So it gave us a domain. Okay, that means this function only exists for the values of x which are less than k. So we want to find the largest value of k for which this is a decreasing function. Now, first of all, let's just sketch this function, and we got to imagine what it looks like here. Whenever you got questions about functions, it's always good to make a little sketch and imagine what the function looks like. So you're going to have basically a parabola, which actually, if you think about it, let's first think about how it will look before we actually start sketching it. You're going to have a parabola shape, which it's going to open upwards because you have a positive in front of the x squared. All right, it's going to have a minimum point. Okay, so it's going to be that type of shape. And the y-intercept is going to be 0, 7. Okay, that's the y-intercept. It goes through 0, 7. Now, does it have an x-intercept? Well, it obviously doesn't, because we can see the vertex of this is going to be 2, 3. The vertex is the lowest point if it opens downwards, and that's given when you write it in this form. When you write it in this form, you can see that the lowest point on this graph is going to be 3 on the y-axis. Okay, it will never ever go below 3 because you're always going to have 3 plus something. 3 plus x minus 2 squared. So it's always going to be 3 plus some positive number. The lowest that this bracket can ever be is 0, okay, when x equals 2. So the vertex is 2, 3. When x equals 2, this becomes 0, and f of x becomes 3. That's the lowest point you can ever have on this graph. All right, so if we sketch the graph without any conditions first, just thinking about it, what it looks like, it's never going to hit the x-axis. So it's going to kind of like turn like this before it hits the x-axis. Okay, and the vertex is going to be at 2, 3. So this is going to be where it reaches its lowest point. That means the y-axis will be somewhere on this side. Okay, if you were to sketch it, the y-axis must be somewhere on this side. Okay, and the graph, okay, is going to look like this. If there was no restrictions, that's how it looked like, right? Now, we want to find the largest value of k for which f is a decreasing function. So we got to understand what this word means, decreasing function. Now, decreasing function is one where the gradient is negative. It's always falling. Like, for example, if I have y equals minus 2x, we know that that graph of y equals minus 2x will be a negative gradient. It will always be going down. But y equals positive 2x will be a graph which will always go up, positive gradient. Okay, so when something is, for all values of x, has a positive gradient, it's going to be an increasing function, and for all the values of x, it is a negative gradient, it will be a decreasing function. So we want to find the value of k such that when x is less than k, this is a decreasing function, the largest value of k. Decreasing function meaning where the gradient is negative. Now we can see that in this parabola, the gradient is negative, okay, when it's going like this, on the right of the vertex. And the gradient is positive on the left of the vertex, on the right of the vertex, sorry. So on the left of the vertex, it has a negative gradient. On the right of the vertex, it has a positive gradient. Okay, so in this region here, it's going to be decreasing. In this region here, it's going to be increasing. We want to find the largest value of k such that it is a decreasing function. So all the way up to this point 2, it will be a decreasing function. So everywhere to the right of it, it's going to be increasing. So that's how it look if we're talking about it being a decreasing function. X is less than 2. So in fact, we should put here an open circle, less than 2. So we can see that this is going to be what k is. K is going to equal 2. So k equals 2, and that's the answer. You can just state it because you can see from the vertex and from the constant from the completing the square that our vertex was 2, 3. So you can write that down if you want to show your step. Therefore, k has to equal 2 because when x is less than 2, it's going to be decreasing. It's going to always be going down. Okay. Now, another way we can also think about this is if we take the original function, which is f of x equals x squared minus 4x plus 7, we can think about this in a way that up to now, at the point where I'm answering this question with the students in my class, we haven't quite got to this part of the syllabus yet, but they should remember it from IGCSE, so I'm going to explain it anyway. And later on, hopefully, once we've gone through this, if you come back to the video, you'll understand better. But basically, another way we can tell when the gradient is negative is by using differentiation. So we can say, okay, let's find the gradient function for this function. The gradient function is what you get when you differentiate. So when you differentiate, you multiply by the power, and you take one from the power. Any term which has an x with it, you just drop the x, and any constant becomes 0. So this is the gradient function. That tells me the gradient of any part of the curve I want to find, and I want to know all the values of x for which the gradient function is negative, when it's less than 0. So we can say when 2x minus 4 is less than 0, so 2x is less than 4, so x is less than 2. So when x is less than 2, this will be a decreasing function. The gradient will always be negative, so therefore we can say k equals 2. So that's another way of doing it, of understanding how to do it. Okay, so you don't really have to show any steps for this question, and the intention really, I think, of this question is for you to use the fact that the vertex, the x value of the vertex is 2, and you can just write down k equals 2 directly from that. Okay, but that's an alternative way of understanding it. A decreasing function is where the gradient is negative. You find the gradient function, use an inequality, you want to find all the values of x, which is less than 0. So all the values of x less than 2 is going to be when it has a negative gradient, as we can see. So therefore k equals 2. That's the value of the number we have to put there for this to be a decreasing function. All right, so that's the answer to part 2. Now I'm going to also explain something else. Sometimes they might ask the same question in a different way. They might ask this question by saying, state the largest value of k for which f has an inverse. For which f has an inverse. Okay, now a function has an inverse when the original function is 1 to 1. If the original function is 1 to many, many to 1, like something that goes down and then up again, any function that has part of it decreasing and part of it increasing, okay, if it changes from increasing to decreasing or vice versa, then it's going to be a many to 1 function, and it won't have an inverse because the inverse will be 1 to many. Okay, so for a function to have an inverse, it must be 1 to 1, right? So for this to be a function which has an inverse, okay, and we know that the domain is x is less than k, right, less than k. For it to have an inverse, the highest that k can be is 2, such that it will be 1 to 1. All right. If it said x is greater than k, then we'll say, then k is again going to be equal to 2. All right, because that's they'll ask it as the lowest value of k for which that has an inverse. That's what they'll say. And if, for example, the question could have been, state the lowest value of k for which f is an increasing function. In that case, we'll be looking at this side of it. And we'll say, okay, the lowest value of k will be 2 for it to be increasing, because then it will always be positive. So those are some variations of this question that you could have, okay, that you should look out for. All right, it's very common for the question to be asked similar to this, where it says state the largest value of k for which f has an inverse. Okay, and the answer will be the same answer as that, because for it to be increasing, if it's only increasing or only decreasing, it will have an inverse. But if it's increasing and decreasing, it won't have an inverse. Because increasing and decreasing means one to many. Inverse will be many to one. So increasing and decreasing means many to one. Inverse will be one to many. So it won't be a function. All right, so I hope that's clear. That's part 1 and part 2 done. All right, so part 3 now. It says the value of k is now given to be 1. Find an expression for the inverse function and state the domain of f of x. So now they've told us that they have that the inverse function is going to be defined with the domain. Sorry, the original function f of x is going to be defined with the domain x is less than 1. So our original function is now f of x equals x squared minus 4x plus 7, and our domain is x is less than 1. Okay, k is 1. So we can think of this as f of x equals x minus 2 squared plus 3, okay, and x is less than 1. So we're now asked to find an expression for the inverse function and then state the domain of the inverse function. Okay, so first of all, let's deal with the expression for the inverse function. Now, when we want to find the inverse of a quadratic function, then we should always complete the square first. So we only have one x term and one y term. All right, so f of x, first of all, you can say let f of x be y. So you have y equals x minus 2 squared plus 3. Now, we want to have only one x term, one y term. If we were starting with this, we would first complete the square. So then it makes it easy for us to change the subject of this formula. Now, before we change the subject, I'm going to switch the x for y. I'm going to switch the y for x. Because now when I go through the process of making y the subject, I will have to go through the inverse operations that this x went through. And I'll end up with the inverse function. So first of all, I'm going to subtract 3 from both sides. So I have y minus 2 squared equals x minus 3. So I have y minus 2 squared equals x minus 3. Now I know that if I square something and I get x minus 3, then that thing could have been either the positive or negative of x minus 3. So I'm squaring both sides. That means I could have had either positive or negative square root of x minus 3. Now, I can't have both of them. It must only be one of them. Okay, so which one is it going to be? That's where we have to think a little bit, right? Now, think about the graph that we have, okay, of what we just drew a bit there. I'm going to talk about the graph first as if there's no restriction. We determined that it doesn't cross the x-axis, that it crosses the y-axis at 7, and the vertex is at 2, 3. Okay, but for this particular graph, it's going to start when x is less than 1. So it's going to start from here somewhere. We're going to get rid of everything else before it. But before I do that, in general, when you have a quadratic and you want to find the inverse, now if your domain is restricted, of course for the inverse, the domain has to be restricted up to the vertex at least. Okay, now if your domain is restricted to the left of the vertex, then you always choose the negative square root. Okay, but if it's restricted to the right of the vertex, you choose a positive square root. All right, because we know that if we just think of y equals x squared, the inverse of y equals x squared would be something that would be like this. So if it's not restricted, then of course it won't be a function. But you can see that the inverse is a reflection in the line y equals x. Okay, and the positive square root, its reflection is, so the positive to the right of the vertex, its reflection will be the positive square root. And to the left of the vertex, if you look at the left of the vertex, its reflection will be the negative square root. Okay, so if you have restricted your domain to the left of the vertex, then we choose the negative square root. If it's to the right of the vertex, we choose a positive square root. And we are limited here from x equals 1. Okay, which will be up here somewhere. Okay, so we get rid of all of this stuff before it, or after it, you could say. Okay, so we know when x equals 1, if x equals 1, y is equal to 1 plus 3, which is 4. So we know that this is going to be 4. We don't need to know that for this part of the question. But basically, we can see that it's to the left of the vertex. So therefore, we're going to choose a negative square root only. Okay, so that's one way of working out which square root. You can work it out kind of visually. You can see we're restricted to the left of the vertex, so we're going to use the negative square root. If we're restricted to the right of it, we'll use the positive square root. So we can say y equals 2 minus the square root of x minus 3. Okay, now, supposing you didn't understand that, or you're not sure, or you forgot which way we have to, if it's right or left, you forgot which way it is, you weren't sure about that. There's another way we can work out what we need. So we've got the inverse function now is 2 minus root of x minus 3. Now, if you weren't sure whether it's plus or minus, we could do something very simple to be sure. So I'll just put this a little bit separate here. So we could start off with the original function, which is x minus 2 squared plus 3. And we can say, let's substitute 0 into the original function. If you put 0 into the original function, you're going to have minus 2 squared plus 3, which is 4 plus 3, which is 7. Okay, so we know that f0 equals 7. Therefore, we know that the inverse of, if you put 7 into the inverse function, it has to give you 0. Because the inverse function undoes or reverses the original function. So if putting 0 into the original function gives you 7, putting 7 into the inverse function must give you 0. So let's see what happens, okay, when we put 7 into the inverse function. And we weren't sure, so we have 2 plus or minus the square root of x minus 3. So let's try first. Let's try first putting 7 into the inverse function. If we took 2 plus the square root of x minus 3, what's it going to give us? So you're going to have 2 plus, instead of x, we're going to have 7. So you have the square root of 7 minus 3, which is the square root of 4, which is 2. 2 plus 2 is equal to 4. So we can see that f minus 1, 7 does not equal 0. So therefore, it can't be this. It can't be plus. And just to confirm, when we put inverse of, if we put 7 into the inverse function with a negative 1, we see we're going to get 2 minus, and we're going to have 0, so x equals 7 minus 3, which is 4. So 2 minus root 4, which is 2 minus 2, which is 0. So we can see in this case, putting 7 to the inverse function did give us back to the original. So therefore, we know that it's the negative 1. So we for sure know this is the right equation. Now, the next part of the question says, and state the domain of the inverse function. Now, I've drawn here our function y equals f of x with this restriction. And we've worked out that this is going to be 4. This is where it's going to start from, 4. It's going to be an open circle, and it's going to go like this. So the range of a function are all the output values. Now here the output values, the y values, will start from 4, not including 4, above 4, and it'll go on to positive infinity. It's going to go up forever. Okay, so we can see that the range of f of x, the range of the original function, okay, so we can say the range of f of x, not the inverse of the original function, is basically y is greater than 4. And we know that the domain of the inverse, is the range of the original. So we can therefore say that the domain of the inverse function is x is greater than 4, because we always call the domain x. So we can say our inverse function therefore is equal to 2 minus the square root of x minus 3, and the domain is x is greater than 4. And there's the answer to this first question, or this part 3 is this of the question. Okay, so what I'm going to do is, because the video is already quite long, I'm going to answer part 4 in a separate video, and I will put a link at the end of that video to this question, and I'll also put a link at the end of that video, this video, to that question, and vice versa, so that at the end of the next video you could, if you didn't see the first part, you will be able to see this part, and if you want to see the next part of this video, you can just click the link at the end. It will also be in the playlist, so you'll be able to find all the questions from this paper that I have answered from the February-March 2019 paper. You'll find the other questions, if I've answered them, in this playlist that will appear in this region here. Other questions from this worksheet, the end of topic worksheet number 4 from functions from my P1 collection, will be found in the playlist over here. You can see other questions dealing with functions from P1 of Cambridge from this playlist over here. And if you click the link on this section here, it will take you to part 4 of this question. Okay, and so have a look out for that if you want to watch the next part of the question. Thank you for watching, and see you soon.